We're here in Adlington, Lancashire today to visit Pincroft, textile dyers, printers and finishers, to look at their environmental improvements, in particular water savings, that have helped them go from a £4 million turnover in 1985 to the £75 million they are today. Let's go and have a look what they've done. Pincroft is one of the largest, most modern, independent commission textile dyeing, printing and finishing operations in Europe. In the last 25 years they've specialised in producing high quality dyed and printed fabrics, end uses such as work and career wear, healthcare, furnishings and specialist military applications. So here we are in the heart of Pincroft. Pincroft makes a very interesting study because they abstract their water from river, treat it, use it within the process and discharge it to sewer. So the real costs of water are artificially low for this site in that they only pay effluent charges, although they're quite high at some £750,000 a year. So what did Pincroft do to achieve water efficiency savings? Well, they initially cherry-picked the obvious, running hoses, leaks, etc. Then moved on to undertake a water mass balance. They installed a water meter, looked at the process efficiency, identified where water was being used and where it was being wasted, and then they moved on even further to look at process operational issues, including the chemistry of the process itself, which they managed to change to save even more water. Currently, water efficiency savings have enabled them to reduce their water consumption and hence effluent discharge from something like 110 cubic metres an hour to where they are today at about 70 cubic metres an hour. But perhaps as importantly, this has enabled them to reduce their costs by something like £500,000 a year.
Initially we looked at quick wins, so first things we looked at were process improvements through technology and new equipment. Secondly, we looked at recovering and recycling water wherever possible. And thirdly, we looked at a water balance, where we measure the incoming water and compare it to the water that leaves the factory and look for opportunities for savings there. The way that we've approached mass balance is to install a sophisticated water meter at the start of the factory. This allows us to profile the water consumption on an hourly basis while the plant's running, and also look at the profile of water use when the factory is not running. And not surprisingly, we found there was a lot of water being used when the factory, in theory, was stopped.
So here we are where the water comes into Pincroft. It comes in through this main here, is treated by this filtration system, and then flows through a flow meter installed on the main incoming pipe to the factory. Now that water meter, the display of which is shown here, enables Pincroft to monitor the instantaneous water consumption, but also it trends the continuous supply of water, enabling the average and past pattern of water consumption to be identified. By looking at this and comparing the water consumption to the expected water use in the factory, Pincroft were able to identify cooling water used on two of the rollers on the machine behind us being used as once through cooling water and discharged to effluent as clean water, which is now recovered and put back in the reservoir just behind this wall here for reuse. It also enabled them to identify that the silk screen printing process had a couple of faulty valves which were allowing water to bypass those valves when the machine was even switched off. That was using some 8 cubic metres an hour for about 40 hours a week. They immediately replaced those valves, preventing that loss of water.
The savings that we made through the water balance, I would estimate at 10% of our total savings. We've reduced wastage on hose pipes that were left running, processed cooling water that was left running when the plant had actually stopped, and also valves that were left on when the plant had stopped. So to demonstrate that quite simply, we spent less than £1,000 on improving valves and amending some pipe work, and that's generated a saving of more than £50,000 a year.
One of the largest uses of water in any industrial process is for washing and rinsing. At Pincroft it's no different. They use water in the dyeing process to rinse off dye from the dyed material. By reviewing this process and changing the fastness of the dyes, and also looking at the quality of water produced from that process, Pincroft have been able to recover that rinse water and use it elsewhere. They've invested about £10,000 worth of equipment, including this tank here, to recover the used rinse water, and from this tank it's then pumped for use in low-grade uses elsewhere on the site. In this particular case it's used for the bar rinsing and the screen rinsing in the screen printing process, replacing fresh water that would have otherwise been used, saving about 10,000 cubic metres of water a year, or financially about £20,000 a year.
Last year alone I would estimate our savings to be in excess of £500,000. Those savings have come from investment on some new technology. They've come from eliminating waste and recycling and reusing water in non-critical cleaning areas.
Whilst I don't expect that every industrial site has a dyeing process on it, the concept of taking a used water and using it for a low-grade use elsewhere is sound water efficiency practice.
It's had a massive effect on the Pincroft business. Water is very important to us. We use water for applying dye stuffs, applying chemicals, washing fabric, washing machinery between processes. So any possibility to save water, we save on environmental costs in effluent treatment, we save on the associated costs of heating that water and disposing of that water. So yes, very important. So a 30% reduction in our water usage has a effect of not only reducing our effluent bills, but also our energy costs.
Behind me is the bleaching line. Pincroft furthered their water reduction measures by looking at the process chemistry. Initially, this rinsing process behind me was completed using a caustic solution to remove the bleaching chemicals. On investigation, it was shown that this could be undertaken just as successfully, in fact more so, by changing the caustic for extractive detergents. What that did was eliminate the need for caustic and reduce the amount of water need for rinsing out those chemicals, because the detergents rinse out of the fabric easier than the caustic. So that enabled the quantity of water to also be reduced. So as we're looking at hidden costs, these process changes enabled the amount of chemical to be reduced in terms of the caustic, replaced by a cheaper extractive detergent, and enabled easier rinsing. On the machine, accurate metering was also fitted to enable the flow of rinse water into the process to be accurately controlled and varied depending on the speed of material through the process and the weight of that material. Hence, the demand for water for rinsing can be accurately controlled to precisely what is required, enabling further water reduction.
We made a large investment 2 years ago where we installed a new wash range onto one of our process machines. The new technology on that wash range allowed us to use 30% less water, allowed us to separate the chemical stream and the water stream, allowing us to recover the chemical and recycle the water back for reuse within the process. So an investment in the region of £750,000 generated a payback of £400,000 per year in effluent savings, energy savings as well as the water savings.
Here in the mercerising process, fabric is treated with caustic solution to swell the fibres and increase the lustre, dye affinity and chemical reactivity. Previously, the caustic was then neutralised using acetic acid and washed off to drain. Questioning fundamentals allowed Pincroft to modify the process by eliminating the use of acetic acid and washing the caustic out using water in more washing stages, which they increased from 5 to 7. Wash water containing caustic is now taken to a new vacuum evaporation system where water is evaporated off under vacuum to concentrate up the caustic solution that can then be reused. Although investment in this process change was high at £750,000, it enables the site to save 800 tonnes a year of caustic, 70 tonnes a year of acetic acid and over 250,000 cubic metres a year of hot water, giving total savings in excess of £400,000 a year.
This initiative will definitely have to continue. We've been very successful over the last couple of years, and that success has encouraged us to continue looking for further improvements. New technology and filtration techniques will certainly allow us to filter out and recover water in processes that currently we've not been able to. The advice I would give to anybody on water improvement is to install water metering equipment. Without that metering equipment, it's impossible to accurately determine where the wastage and when the wastage is, and without the measurement, it's impossible to improve it.
Okay, well that concludes our quick overview of water efficiency savings that Pincroft have made. And I hope you can see that they vary from the simple, big savings from a simple water mass balance evaluation through to the more technical and complex issues which have a lot of hidden costs. And perhaps more importantly, it shows that Pincroft are continuing with water efficiency improvement measures to achieve those water and financial savings. So some of the ideas are laid in front of you, over to you. Hopefully you can pick them up. And just remember, save water, save money.